All right, let's, I was thinking I should say like the date and all that kind of stuff. Is that important at all?
You should have like
Paco, what's wrong?
no,
You want me to get started? Okay. What's that?
nothing to do with you.
Oh, now he's in your
Is it
way?
because I'm in front of you?
I can't see. All right, so here we go. This is section 13.2. And we have to do this kind of quick. So let's just talk about this thing right here. Let's make a little x and y axis. We're going to talk about angles, and we're going to talk about how to measure them, where do you start, and where do you end, and all that kind of stuff. So let me just draw myself just a little x and y axis right here. And we'll make the angle in a different color. And let's do this. Let's make the angle go about right there. Is that all right? Now, I'm not going to put arrows on here. I think there is a thing on here where you could put arrows, but I'm not going to. Why is that red? I want that black. All right. Can you see that all right?
Mm-hmm.
Yeah. Oh, hit a light. Hunter, would you mind, or somebody? And if I wanted to, I could do this as well. You'll see this in the book. They put the, normally I wouldn't put both of these things here, but really an angle is made up, if you remember in geometry, an angle is made up of two rays. And let me just pop that up a little bit so you can see it. All right, can you see that red on top of that blue right there? Okay. So there's your angle right there. Now what we want to do, I mean this could be, you could be talking about this angle, and who knows, you could talk about this one right here, right? You could talk about just that right angle. Who knows what we're talking about here. So we have to have a way where everybody's on the same page and everybody's looking at it exactly the same way. So what we're doing here, let's go back to black color. And this right here is the x-axis, obviously, and this is to the right, so this is the positive x-axis. So when we describe this angle, if I want to talk about what this angle is, we always start from the positive x-axis and we go counterclockwise until we hit that other side. Okay? So that's how we measure an angle. We always start from the positive x-axis and we go counterclockwise until we hit the other end of the angle. I'm not going to write this down just due to time, but this side right here they call the initial side because the initial is where you start. Okay, so an angle, again, like I said, is made up of two rays. Normally, I probably wouldn't write both of them on here. If I was going to write this angle, I would probably just start here, come out like this, and not have this one right here. That kind of makes sense, doesn't it? So if I wanted to say what this angle measurement is, I always start from the positive x-axis and I go counterclockwise until I hit this. They call this the initial side, and they call this one the terminal side. Okay, terminal means the end. Okay, so that's the terminal side, and this is the initial side. Now watch, that positive x-axis is where we start. So we're going to measure this angle in degrees. So where would you start? What number would you start if you're going to say it?
0.
It's 0, right. So this right here would be 0 degrees, right? Now if you go way up here, what do you think this is?
90.
Right, because it looks like it forms a right angle, doesn't it? Yep. So that would be 90 degrees because it's perpendicular. Let's keep going. Talk to me.
180.
180. And this one would be? Is Johnny the only one talking? All right, so 0, 90, 180, 270. Everybody with me on this? Now let's just say this angle is, I don't know, what do you think? Like 40. I was going to go 45, but let's just say it's 40. All right, and if I said, what is the measure of this angle, we'll call it. All right. I'll put a little arrow right there. Okay, so here's our angle. If I said, what's the measure of that angle? Well, it's obviously not 40 degrees, is it? What is it? You start here, you go to here, and how would you figure that out? It's pretty easy.
90 minus 40.
Well, you wouldn't, to find this one right in here, you would go 90 minus 40. Yeah, you could do that. What would be an easier way, though? Yeah, just 180 minus 40. That would be easier, wouldn't it?
That will be.
Okay, so from here, you could do it that way. It would be fine, but I think it's easier going from here all the way to here, which is 180. And then I always say this. I say you back up 40, right? Go backwards 40. And so 180 minus 40 is what? 140. So this angle right here would be 140 degrees. Make sense? We just have to make sure that we all are on the same page on this. We're all, start our angles from the same spot, we go in the correct direction. Now, I'm going to keep this graph. Let's just go different color. Let's go green. And let's go the other way. What if, let's say the same angle. Okay, here's the initial side, and what was this side? What do we call it? Terminal side. I didn't write it down, but you're taking notes, aren't you? You're not just waiting for this to go on YouTube, are you? But then it's so much extra work. You got to go home and you got to sit there and listen to me twice. You don't want to do that, do you? All right, so look at this angle right here. What if we went in the other direction? We went clockwise. Remember, if we went counterclockwise, that's positive. It kind of seems a little odd, where you think counterclockwise would be negative, don't you? Because counter is the opposite way. But it's really the positive direction. If you go clockwise, then this would be, what do you think?
Negative.
It would be negative. So let's find this angle. It's the same exact angle, isn't it? All right, we didn't change the angle at all. So we said this angle right here is 140 degrees positive, or we could also write it as a negative angle. So if I take this and I write it in the other direction, what do you think that would be? This would be, from here to here would be 180. Now we wouldn't subtract a 40. What would we do? We'd add a 40. So what would that angle be? 220, that's right. So that angle down here would be 220 degrees, but not 220. We went in the other direction, so tell me. It'd be negative 220. Okay, so go in the opposite direction. So when we go clockwise, right, this is clockwise, the way a clock goes, and that would be actually the opposite direction, all right? So when we go down, and you could think of that, you know, if you're starting from the positive axis and you start down, that's negative, isn't it? If you start from the positive x-axis and you go what? Up and around, that's positive. That kind of makes sense, doesn't it? It's a little more intuitive than counterclockwise and all that kind of stuff. All right. Yeah, that's pretty easy. Let's see what else is next. All right, we can also have, I'm going to try to copy. Group, copy, paste. Oh, look at that. Should have had that already prepared, but that didn't take too long. All right, there's my x and y axis again. We can also do this. Let's put another angle in there. Let's just go somewhere different. In fact, let's just stay in the first quadrant. Make it, oops, I've got to turn it to the pen. There we go. Let's stay in the first quadrant, and I need to, I don't want it so jaggy. I want it like this. Change the color. Okay. Oh, when I touched that, it went red, didn't it? That's why. That's okay. Who cares? I really don't that much. And okay, that's a little better. Okay, let's say this angle right here, and let's just say it's 30 degrees. It's probably more than 30 degrees, but we'll just say it's 30. Now, there's a couple ways to say this. We could say it's 30 degrees, or we could, that's positive 30, right, because it's going up. Or we could say, what would the negative be if we went all the way around like this? What do you think?
Negative 330.
Negative 330, good, because if you go all the way around, that's 360. We all know that. You back up 30 more, 360 minus 30 is 330. Everybody got that? It's pretty easy. But you could also, you watch the Olympics, right? And Shaun White, you see that guy? It's crazy, dude, isn't he? I mean, he goes up there, does all those spins. I mean, you see that all the time. You see it in skateboarding, you see it in skiing and snowboarding and just bicycling, almost everything, except for car racing. They don't do too many 360s in car racing, except at the end, right? They do the spinning around. Well, anyway, but they throw all these numbers out. I mean, they flip and turn so fast, you can't even count how many times. But these guys who watch it all the time, they're like, wow, he did I don't know, what's that dumb commercial where he sprays himself? A double twist McFlippy or whatever. What's that thing? To chesty or I don't know. But anyway, but they're throwing out these crazy words, right? They're saying, whoa, look at that 720, or look at that. What was another one? It was, yeah, they know exactly what they're going to do and all that, you know. Oh, he did a 700, blah, and they're going crazy and all that. Well, what's those numbers? What in the world are those numbers? They're degrees, right. So you can actually go around more than 360. I've had people say, you can't go more than 360. You can't go more than once around. I'm sure you can. You can spin, right? These guys dunk, you know, 360 dunks. You've heard of that. But I guess, I don't know, do people spin even more? My time's running out?
Yeah.
Oh, my word. Okay. Let's stop and we'll go to another frame.